In this video, another way to prepare is to watch this video where I'm going to go through the point-free example in the lecture. So once you download the code and unzip it, you will have this folder here which you can then open up in Visual Studio Code, and you'll find in the source directory a file called pointfree.hs, and it looks like this. Let's change the theme, let's make it light. Okay, so here's our code. We can run the tests for this code from the terminal like so. Make sure you're in the directory and then run stack test, and that will compile everything. Okay, so now whenever I save this file, it runs the tests like so. Let's make that a little bit smaller. Maybe make our code a little bit smaller. Close this. Now, you can see already I've got some syntax highlighting going on, and it's HLint running and giving us a suggestion that we can refactor the code. This is happening because I have some extensions installed in VS Code. I have Haskell syntax highlighting, which is very nice. I also have a Haskell linter, and I have a plugin called Haskero. These are useful but not essential, but they do things like suggesting changes, like we can see here. So it's suggesting that we can apply eta reduction, which we know about from learning about the lambda calculus. It's saying that this argument L is it's redundant writing it, because in fact because these are curried functions, we can apply the rule, and you can see it's taken away the L. So that was the VS Code extension doing that for me. It's now refactored it and taken that L out, because whatever this below function gets called with will that parameter will be passed through. We can do the same down here, and that's taken away a little bit of the noise in our code. It's a little bit cleaner, arguably. When we save this again, we can see that the tests all still pass, so it's been refactored, but it's functionally identical. All right. However, we can do more. We can, in fact, get rid of the remaining argument for this below and above function. To do that, we're going to use the compose operator. Remember that compose is composing two functions in Haskell. Looks like this. You go f.g, which is the same. This is not code I'm writing, this is just notes, which is the same as applying f to the result of g. So if I pass an argument in f of g of x, those two expressions are entirely the same. Okay, so how can we use compose here? Well, first we've got to do a little bit of manipulation. How can we apply compose to somehow remove this argument? What we would like to, where we want to get to, is composing partition with the less than operator such that the p doesn't need to be explicitly written anymore. How can we do that? Well, the first thing we'll need to do is realize that less than p is the same as p greater than. Okay, so now greater than, previously p was being passed in as the second argument to less than, now it's being passed in as the first argument to greater than. So that means that when we rewrite that code, so it's like that, now we've taken out the greater than, and by putting it in brackets, it's now gone from being an infix function, a function that goes between its two arguments, to a prefix function, which means that the function name is written before the arguments. And we can see that HLint is again, it's suggesting that it will be a bit nicer if we go back to the way it was. It's saying use operator sectioning to go back to how it was. But we're not going to do that. Instead, we're going to do something that HLint doesn't know about. So we're going to observe that that part P is in the same form as the function application we saw before, so f of g of x. And we said that f of g of x is the same as f dot g of x. So g in this case is the greater than function, and f is the part function. So we can rewrite this in this form, and it will be equivalent. So let's do that. Okay, do our tests still run? Yes, they do. And look, HLint is saying we can eta reduce again. Our P is now no longer necessary, so it's removed it. And look, HLint says we can do something else again. So we've got redundant brackets, like so. Now, we can do the same thing down here. So greater than equals P is the same as P is less than or equals, which is the same as this, which is the same as this, which we can eta reduce and then remove the extra brackets, and our code is a little bit cleaner. These two functions are now point free. Okay, we're going to do some more work in the lecture, refactoring this line as well, and refactoring the code up here to make it read a little bit more like English. And these point-free rules that we're learning are applicable to all kinds of code, and you will see Haskell code written in this style frequently in the wild, so it's worth recognizing it when you see it, and recognizing that functions written in this way have all the noise of arguments taken away and are simplified to their essence, arguably. It's not essential that you do this when you write code, but it's something that you will see in the wild and something that you should know about. Okay, that's enough for now. I look forward to seeing you in the lecture next week.